I'd like you to first pause the video and read the question carefully, and then we'll discuss which method to use for this particular problem. So there is a new drug that is being tested here, and it's a treatment for hormone secretion problems, and it's tested on lab rats. It seems to be working and doing what it's supposed to do. However, there is a side effect, which is weight gain, and that's what they're trying to figure out here. Is there this additional outcome of weight increasing after the new drug has been administered? So a random sample of 4 rats, okay, so we have 4 rats, have been treated with the drug, and what we're concerned about is weight. So the weight before the treatment is measured and the weight after the treatment is measured. And scientists want to see if there is a significant amount of weight gain after this treatment has been administered. So the question says, are we convinced that the treatment with the drug increases weight? So first, let's determine if this is a single sample problem. Is it a matched pair problem where a single sample procedure is used, or is it a 2 independent sample problem? So let's look at this. There are 4 rats, so n equals 4, and the same sample of rats have been measured twice, one before the treatment and one after the treatment. So the numbers that you see here in 2 different rows are coming from the same rat. So the same rat is weighed before and after. So we do not have 2 independent samples here. There is only one sample of rats, which is 4 rats, and the same rats are giving us these 2 rows of numbers, which is the weight measured before and the weight measured after, but it's the same rat. So this is what makes it a matched pair problem. So it's a matched pair design. Same sample is used, so it's really a single sample problem, but only after we have taken the difference in the values. So if it's a matched pair problem, we need to turn it into a single sample problem by taking the difference in the measurement. Let's say this is after the treatment, this is before the treatment. So after minus before is the difference. So we have after minus before, and I've written down all the differences after minus before. Just make sure you're consistent once you decide which way you're going. Next, let's read the question. It says, are we convinced that the treatment with the drug increases weight? So the way the question is asked, you're going to say yes it does or no it doesn't, and of course provide evidence, which tells us that this is a hypothesis test and not where we're estimating the difference, which would be done using a confidence interval. So a question like this, are we convinced? And your answer would be yes or no, depending on whether you can provide evidence for what you're saying is true, right? So we want to either prove that there is weight gain, or then eventually we may come up with a situation where we don't have enough evidence to prove that there is a weight gain. Now, the next step is, let's write down the statement. So we use the 4-step procedure as in the textbook, so it's state. So here we're going to say, we will find evidence that the treatment with the drug increases weight. That's what we are trying to prove. So your first step always is state. So in this part of the problem, that is the first step, we're going to write down what we are asked to do in this particular problem. So there are only two types of problems that you will get, and one is estimate the mean or find evidence, which is either construct a confidence interval to estimate the mean or do a hypothesis test to prove something. So in this case, we've decided it's a matched pair problem, and then what we're trying to do is find evidence that the treatment with the drug increases weight in rats. Now the next step is formulate. So here what you need to do is write down your thought process. When we read the question, we said it looks like we have 2 rows of data, but it's the same sample of 4 rats that are giving us the after measurements and the before measurements. So what that tells us that it's a matched pair procedure. So that is what we write down in this step. So in formulate, you provide an explanation of why you're using a certain procedure. So since the before and after weight measurements are coming from the same sample of rats, this is a matched pair problem. We've explained why we are using a matched pair procedure. We'll use a single sample t procedure to do the hypothesis test, and this is how you would get the t statistic for the hypothesis test. Next, we do the solve part of the problem, the math part of it. So that's step 3. What we start with, if it is a hypothesis test, it is absolutely necessary to start with the null and alternative hypothesis. If it is a matched pair problem, it turns into a single sample t procedure, which means you have only one mu, which is mu is the population mean. So here we have only one variable, which is the difference in the 2 readings, and this is the mu is the mean difference. So HO is always what we are trying to fight against, which means there is no difference in the weights when we compare the before and the after, which means that if we say there is no difference in the weights, then the difference is equal to 0. That's where the 0 comes from. So the mean difference, you can call it mu d difference, because that's the new row that we created of the difference. So mu equals 0. If there is a weight gain, after minus before should be a positive number, which means it has to be greater than 0. So mu has to be greater than 0. And now we do our calculations using the formula t equals x bar minus mu o divided by s over radical n. Mu o is this number. N is equal to 4 because that's the sample size. X bar and s we get from our calculators by entering the data, and when I mean enter the data, it would have to be entered into your calculator. And what exactly? So once we are done with these 2 rows in a matched pair procedures, we don't care about the original data, we only care about the difference, right? So these are the numbers we enter into our calculator. So my calculator, when I entered these numbers, which is the differences, which is what I entered, this is what I got. X bar is 25 grams. X bar is the mean of the sample. S is 40.41 grams. So these are the 2 numbers I got from my calculator. I used the statistics function on the calculator to do this. And once this is done, we calculate t, which means plug in the numbers. 25 minus 0 divided by s, which is 40.41 divided by radical n. So when we use our calculator to solve this. We calculate this, we get 1.24. Be careful when you're entering numbers into your calculator. It's 25 divided by open parentheses 40.41 divided by radical. Make sure it's a 4. Sometimes your calculator will open a parentheses. Make sure you close it and then close your big parentheses. There's a big one here that has to be closed, and you get 1.24. So once we get the t value, the next step is to find the p value. This is the t statistic. We find the p value because that's our evidence in a hypothesis test. For a t procedure, we go to table C. In order to use table C, we need to know degrees of freedom, which is sample size minus 1, 4 minus 1, which is 3 degrees of freedom. Make sure you're using table C on the exam. That will be given to you. No other form will be acceptable. So use table C. So here is table C, and we're looking at degrees of freedom 3. So we're looking at the third row here. Our t statistic lies between these two numbers. It's 1.24, and it lies between 0.978 and 1.250. So we go down that column, and since it is a one-sided p-value, we're looking at this number and this number. So our p-value lies between 0.15 and 20. It's a one-sided p-value because mu greater than 0 is our alternative hypothesis, HA. So that's why it's one-sided. If it were not equal to, then that would have been a two-sided hypothesis. So here we have a one-sided test. So the p-value is between 0.15 and 0.20. So our t statistic based on the table lies between 0.978 and 1.250. The p-value one-sided for 1.250 is 1.5. It's a smaller number, that's why we put it on the left. The larger number, which is the one-sided p-value for 0.978, is 0.20, goes on the right. So this is our p-value. Our significance level, if nothing is specified, is 0.05, which is the same as 5%. Now, definitely, if the p-value lies between these two numbers, we can be sure that it's greater than 0.05. 0.05 is way less than 0.15 and 0.20. Our p-value is here, and 0.05 is here. So this is greater than, the p-value is greater than 0.05, which means we fail to reject. It's always about HO. You either reject HO or you fail to reject HO. So we failed to reject HO, which means we do not have enough evidence to prove that there is a difference in the, or there is a weight gain in the rats. Basically, we have no evidence against the statement, which is HO, which tells us that there is no difference. And basically, we don't have enough evidence to prove that wrong. So therefore, we make a conclusion. So this is the conclusion. We do not have enough evidence. The minute you say evidence, in parentheses, write down your p-value to prove that there is a weight gain in rats after the drug treatment. Basically, we have nothing against the null hypothesis, no evidence against the null hypothesis. So this is how you solve a matched pair problem. And in addition, I've explained exactly how to write down the state, formulate, solve, and conclude. So these are the 4 important steps that you have to go through in order to complete a hypothesis test or a confidence interval, depending on the question that has been asked.